Okay, so for this one I got a cantilever beam loaded like that, and I want to find the slope at the midpoint and the deflection at B. Now, the way I'm going to break this guy up using the guys that I got, because I've only got the distributed load next to the fixed support, is I'm going to break it up like this. I'm going to have my beam like this. I'll take the entire distributed load, and what I'm going to do is I'll add that to a distributed load going in the opposite direction like this. Okay, and that's what I'm going to add together, right? So I get all that down and then just at that going up. So I'm basically going to subtract the two, so what I have left over is that one. So what I'll do for the slope, I'm going to use this equation, and what I'm going to actually do is I'm going to take a derivative of it to find the slope, right? And that's basically how a derivative is. For the second one, all I need to do is use this guy, because after that midpoint, the slope is exactly the same. Once it hits that midpoint with no load there, it just keeps going at that. So the maximum slope is the slope at the midpoint. And really, it's the same slope from on that picture L over 2 all the way to the end, or for R's from A up to A over 2 with that slope. It just kind of continues on that slope. Okay, so for the first guy, I'm going to take the derivative of that. I'm going to put the x, so it'll be x to the fourth and x cubed and then x squared. Okay. So what I'm going to wind up getting on this when I do that is I'm going to put the x back in there. Okay, so 24 EI like so. Okay, so instead of x squared, I'm going to have x to the fourth, so the derivative of that would be 4x cubed, okay, minus 12L x squared for the next one, right? Because again, x, instead of x, it'll be x cubed. So I bring that down and get the 12. And then I'm going to have plus 12L squared times x for the last one. Again, I distribute that x squared, this x squared. I distribute it back in to all of those, okay, and figure it out from that. Now, what I'm going to do here is for x, every place I see x, I'm going to, I guess I'm going to plug in a. Okay, so this becomes a, that becomes a, and this becomes a. Everywhere I see L, I'm going to use 2a, right? So that becomes 2a, that becomes 2a. Okay. So just knowing, because again, the length of my thing is 2a that I've got here, and I want to know what's going on at a. Okay. So plugging all that in and manipulating things, I'll let you do the math on your own, but I get negative 7WA cubed over 6EI. Okay, and again, that's what the slope is at A for a 2A length beam with a W distributed load acting on it. Okay, now I'm going to use the other guy, the bottom one, which is just going to be negative W times 2A cubed, okay, all over 48 EI. Okay, simplifying that down, and I get WA over 6 EI. So what I'm going to do now is I'm going to add those two together, right? One is causing a downward slope, that top one with the slope going down. The other is causing an upward slope. Okay, so I'm going to subtract the two. I basically am subtracting negative 7/6. I'm adding negative 7/6 to 1/6, which just leaves me with 1. So that total slope, okay, and this would be at C, then becomes negative WA cubed over EI, just adding those two together. So again, I've got the distributed load over the whole thing going down, and then the distributed load of half of it going up, right? So adding, you know, the negative downward slope to the positive upward slope gives me the total slope at C there. Okay. Now to find the deflection of point B, for that one, I just need these two guys to find that deflection, because the max deflection is going to occur at the end point, so that's where the maximum would be. Okay, so really all I do on that to find the velocity, not the velocity, I'm sorry, the displacement of B, right, the entire thing is going downward, so I'd have minus W, not L, 2A to the fourth, okay, divided by 8EI. Now the other one is going to cause a deflection upward, so I'm going to say plus, instead of the negative, it's going to be upward, or minus a negative, however you want to think about it, and that's going to be 7W 2A to the fourth divided by 384 EI. Okay, so that's pretty straightforward, again, because at the end point it is the max, so I can just add those two things together, plugging in what I know about 2A. From that, I can figure out that my total deflection is then negative, because it's going to be downward overall, 41 WA to the fourth all over 24 EI. So again, you can break this up into pieces. This time I've got two things I'm actually subtracting, or, you know, if you think about it, I've got a distributed load going up to get it to look like the beam that I've got using the appendix pictures that I have in Appendix C from our textbook.